Hey everybody, this is just a quick video on to help you with the CER. I do have my face in it this time, just not that I'm trying to torture you, just because I'm going to show you some images in a little bit or some rocks that I think will help you out. So the rock CER summative assessment. So a few tips and pointers in this video. First of all, which rock sample is pumice? So you were supposed to go through this data table, and you were supposed to try and figure out which one of these four unknown rocks would be pumice. And that's the first thing. That's the first tip. Some of you, probably 5 or 6 of you, you didn't answer this question. So your claim should be something like rock A is pumice, rock B is pumice, rock C is pumice. Some of you didn't answer this question at all. So that's the first thing you got to understand is you're always answering a question. So the second piece of information or tip I will give you, so that was the claim for evidence, you have to include both qualitative and quantitative data. What I mean by quantitative data is you have to have data from this data table. So some of you talked about rocks being light, rocks being heavy, but you never used any of the numbers, and that's the quantitative part of it. You just tried to explain it with words, but you should have data. Now, that doesn't mean you take a screenshot of this whole data table and you put the whole data table in the evidence. Problem with that is I don't know if you know what evidence you're looking at, or you need to tell me what specific evidence to look at. So I had a few of you take screenshots of the whole data table and put it into your evidence. But the problem again with that is I don't know if you're just don't understand what you're doing and you're just taking a screenshot and putting the whole thing there, or if you are wanting me to look at specific pieces of information. So make sure you include data. Don't just take a screenshot and put it in your evidence. Explain the data. You have to use the numbers from your data table. So a bunch of you didn't use any of these numbers at all. You just tried to explain it in words. But again, I'm looking for that quantitative data as well. And then for the reasoning, we have to understand there's really 4 parts to the reasoning. First, you're going to want to restate your claim. So what is your claim? Copy and paste it from above. Then you're going to want to tell me what scientific principle you're using. That's the second thing. Then you have to explain why that scientific explanation is relevant, or that scientific principle is relevant. And then you've got to have a concluding statement. So let's look at these scientific principles here. So you had 4 of them. Number 1, a property such as density, and I just explained what density is, it's mass divided by volume, is a unique characteristic that helps identify a substance and distinguish one substance from another. 2, a substance is made up of only one type of material all the way through. 3, a mixture is made up of more than one substance, or more than one type of atom or molecule. And then 4, properties of a given substance are the same regardless of the amount, mass or volume, of the substance. So you had to pick which one of these 4 would be the most relevant. And in our case, it would have been number 1. Properties such as density is a unique characteristic that helps you identify a substance and distinguish one substance from another. So when I look at this, these weren't exactly the same numbers that you probably had in your lab. No, I did include some lab data to help you out. And you should have had numbers that are similar to this, probably not exactly the same as this. Although with my original lab, I did sample one of the bags. So I don't remember, I've got all the samples behind me. I don't remember exactly which one it is, but your data should be close. Now, here's the problem with a lot of your CERs, and this is why I'm showing you the picture. And let me show you that right away. So this is a piece of pumice. This is a piece of granite. Which one do you think has more mass? Do you think the granite has more mass, or do you think the pumice has more mass? Well, I did mass them on the balance right before this video, and this piece of pumice is 4 times heavier, or has 4 times the mass as this piece of granite. Now, because this piece of granite is much, 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 much lighter than this pumice, does this mean the granite will float? Or do you think the pumice will still float? If you said the pumice, you're correct. So you were supposed to try and find the pumice in the data that you see in the video, and it is obviously C, because we know that anything with a density of less than 1 will float. But a lot of you didn't talk about density at all. You just talked about, pumice is the lightest one. It's the smallest one. And because it's so light, it will float. Well, it doesn't matter. So if we look at scientific principle 1, which is the best one, properties such as density is unique characteristic. So even if you have a very, very small piece of pumice or a very, very large piece of pumice, the density will still be approximately 0.8. Now keep in mind that your densities might be a little bit different. Every rock might be slightly different. There might be some impurities in here that might throw off the density a little bit, and the same thing with your granite. So the densities aren't always going to be exact, but they should be approximate. So even though this rock right here is much, much, much more massive, has more mass than this one, the pumice will still float. Its density will still be approximately 0.8. So a lot of you got it wrong because you focused solely on how small the rock was or how light the rock was. And you talked about how, in our sample, pumice floated because it was the lightest rock. No, it didn't float because it was the lightest rock. It floated because its density was less than 1. And a lot of you use this principle then. Properties of a given substance are the same regardless of the amount of the substance, where the correct scientific principle was number 1. All this means is that you can have a larger, if you wanted to go for an advanced, I would use both 1 and 4 scientific principles. But if you want a proficient, you have to have at least scientific principle number 1. All that 4 means is that if this is larger and you have a smaller piece as well, this is still pumice. So the size of it doesn't matter. It's still pumice. You could have a piece of pumice that might be the size of your car. It'll still float. It'll be very, very large and high in mass, but it'll still float. So what I've done is I've set up a retake, a completely different CER summative assessment, and you are welcome to retake it. Hopefully this video will help clear things up and help you do well on this next test. Now I have changed up the data, so you're going to have new data, so you can't use the same old, this original CER. You're going to have to write a new one. Take your time, focus on density, not how light things are. And the last tip I will tell you is when you're writing these, especially if you're retaking them in class, and I'm at my desk right now, but if you look in the back of the room on the back wall, I have CER posters. A lot of you are putting like your scientific principles in your evidence. You only need your evidence. This will probably only be a sentence or 2. The reasoning should be a good sized paragraph because you need those 4 parts we talked about. And a lot of you are putting your scientific principles here and not here, even though on the posters in the back wall that I encourage you to use, that I tell you to use, that it says to use in the directions, a bunch of you still continue to put the scientific principles here versus here. And the posters will tell you where everything goes. So make sure you use those. Make sure if you're still confused, you ask for help. Thank you.